Okay, this is lesson 11 and we are going to start to study about the exponential equations. Here exponential equations, it should be in form 3 to the power of x plus 2 is equal to 1 when it is given in this form. This is exponential equation, but if there is a polynomial equation like x here, polynomial variable in the equation, it is not called exponential expression. So we have the forms, and the first form that we are going to study, a to the power of fx, a to the power of gx. When the bases are same, it means that when the bases are same, powers must be same. Like 2 to the power of 3, if it is equal to 2 to the power of x, x must be equal to 3. And the same property here. And example also similar with the that I gave. 2 to the power of 3x, if it's equal to 2 to the power of 9, it means that 2 to the power of 3x, if it's equal to 2 to the power of 9, I rewrite this one, but it's not important. 3x, it should be equal to 9. The powers here, this power and this power, should be equal to each other. And here 3x is equal to 9, x is equal to 9 over 3, which is equal to, x is equal to 3. Okay, second one, 7 to the power of x plus 9 is equal to 7 to the power of 2x minus 15. The bases are same, so powers must be same. Here, this power and this power, they are going to be equal to each other. That's why x plus 9 is equal to 2x minus 15. When we say, we are going to finish. X plus 9, x minus 2x, we can say, is equal to minus 15 minus 9. Minus x is equal to minus 24, it's going to be, and x should be equal to 24 in the second one. Okay, the third one, the basis seems different, but actually they are mathematical, multiplicative inverse of each other. We have this form, a over b to the power of n, it should be equal to b over a to the power of minus n. We know this one. So, which one you want to replace? I mean the numerator and denominator. If you want to replace them, here, this 2 or this 2, you may replace them. So, I'm going to replace the second one, 3 over 11 to the power of 3x minus 10 is going to be equal to 3 over 11 to the power of minus 7x minus 10 is going to be. Then 3x minus 10 is equal to minus 7x minus 10. Then 3x minus 10 is equal to minus 7x plus 10. It's going to be here, if you get to the other side, 3x plus 7x is equal to 10 plus 10. 10x is equal to 20. X, it should be equal to 20 over 2, which is equal to 20 over 10, which is equal to 2. Okay, this was the first form. Second form, here, if a to the power of fx is equal to b. In this kind of questions, we are going to use the method logarithm base a, b, it should be equal to fx. Okay. This is going to be logarithmic base. So 3 to the power of, if I solve the a, 3 to the power of x minus 1, if it's equal to 4, it means that x minus 1 is equal to logarithm base 3, 4. And x should be equal to logarithm base 3, 4 plus 1. It must be. And b1 here, the b1, 2 to the power of x squared is equal to 2 to the power of x squared is equal to 3. And I'm going to use the same method. I'm going to send this one to the other side, but this time the base is going to be 2. X squared is equal to logarithm base 2, 3. And we have here x squared, so we need to get the square root of the expression. And x should be equal to plus plus minus, I'm going to say, because when you get the x squared, square root of the x squared, we should write always plus and minus sign, logarithm base 2, 3 is going to be. Or in this question, we are going to write like this for the third question. 3 to the power of 2x minus 3 is equal to, if it is equal to minus 1, this is a bit tricky question, we are going to say no solution. No solution. Why no solution? Because when we have exponential expression, result always must be greater than 0. If it is smaller than 0, this function is undefined. This function is undefined. It means, or this equation is undefined. The answer of this question, when it is negative, it is undefined. So for the fourth one, D, 2 to the power of x when it's equal to 7, it means that x is equal to logarithm base to 7 is going to be, and the last one, 3 to the power of x plus 2. 3 to the power of x plus 2, I'm going to solve the e here. 3 to the power of x plus 2 is equal to 11. Here we can do one more operation. The addition, the power can be written like this: 3 to the power of x times 3 to the power of 2. Then it's equal to 11. 3 to the power of x is equal to 11 over, because this is division and when you send to the other side, it can come as a 9, and 3 to the power of x, this x it's going to fall down, then the answer here on this side it's going to be with logarithm base 3, 11 over 9 can be also. Okay, if we continue to solve questions like this, or new form, here it's going to be for the functions a to the power of fx and b to the power of gx. If the bases are different, we cannot solve every kind of questions, but the powers are, if they include the same coefficients, or here we have x here, pardon, I need to change the color. Here, this is going to be here x, and here we have x, so we can write under the same base. I'm going to explain what I mean. A 2 to the power of x plus 1 is equal to 3 to the power of x minus 2. And 2 to the power of x times 2 is equal to 3 to the power of x times 3 to the power of minus 2 it's going to be. And 2 to the power of x times 2 is going to be equal to 3 to the power of x over 3 to the power of 2. And we are going to try to collect the power exponential expressions like 2 to the power of x and 3 to the power of x on the one side. So I need to send this one to the other side. This is division, so on this side when it comes it's going to be multiplication. So 9 times 2 is equal to 3 to the power of x over 2 to the power of x. And this is going to be equal to 18. 18 is equal to 3 over 2 to the power of x. Now there is only one power here, x, and the expression is, if you rewrite this one here, I'm going to write this one here again. 3 over 2 to the power of x is going to be equal to 18, and when you send this x down, x becomes, this expression becomes logarithmic, the base 3 over 2, 18. Okay, what about this one? For the second one, b 2 to the power of x minus 1 times 5 to the power of x plus 3 is equal to 3. 2 to the power of x times 2 to the power of minus 1 times 5 to the power of x times 5 to the power of 3 is equal to 3. It's going to be here 2 to the power of x times 5 to the power of x. I'm going to send these expressions to the other side, so 3 over 2 to the power of minus 1 times 5 to the power of 3. 2 to the power of minus 1 we can send up, and here on this side 10 to the power of x it's going to be, or we can write like this: if the powers are same, 2 times 5 to the power of x. The formula for this one, a times b to the power of n is going to be a to the power of n times b to the power of n. So here 10 to the power of x is going to be equal to, this one goes up, so it's going to be 3 times 2 over 125. Then 10 to the power of x is equal to 6 over 125. Now this x falls down when you want to find the x value. X is going to be equal to logarithm base 10, 6 over 125 is going to be. Okay, now we are going to solve the similar questions like this. Here we are going to try to find we are going to try to collect the terms to one side with the power x. So it's going to be like this: 3 to the power of x times 3 is equal to 5 to the power of 2 to the power of x times 5 to the power of minus 1. Why I got 5 to the power of 2 then x? Because the powers must be same, and if the power is x here, this power should be also x, and the multiplication means power of power. Okay, 3 to the power of x times 3 is equal to 25 to the power of x times 5 to the power of minus 1. So this is going to be equal to 3 times 3 over 5 to the power of minus 1, 3 times 5 to the power of minus 1 is going to be equal to 25 to the power of x over 3 to the power of x. Okay, this minus 1 will go up, and it will be like this: 3 times 5 to the power of 1, because power is negative, is equal to 25 over 3 to the power of x. And if you want to send the logarithmic form to the other side, it's going to be like this: 25, first let me write this side, x is equal to 15, then x is equal to logarithm base 25 over 3, 15 it should be. Okay, this was the first one, a. This is. Here we are going to do same operations for the other. 3 to the power of x, I'm going to try to get rid of from 1 and minus 1. So 3 to the power of 1, it's going to be times 3 to the power of x times 3 to the power of minus 1 is equal to 5. Then 3 to the power of x times 3 to the power of x is going to be equal to, times here 3, and this is over 3, that's why this is 2, they're going to be simplified, and 3 to the power of 3 times 3 to the power of x is going to be equal to 5. Then x is equal to 9 to the power of x is equal to 5. We may write 9 to the power of x is equal to 5. Then x is equal to logarithm base 9, 5 it's going to be. Okay, all the powers are here, they are different, so I'm going to write in terms of 2 to the power of 2 to the power of x times 3 to the power of 3 to the power of x is equal to 5 to the power of 5 to the power of x times 7 to the power of 7 to the power of x. It's going to be this expression. This is the C1. Okay, and we are going to collect the terms one side, so we are going to send these are to the other side and this one to the other side, but we should leave here 1. So it's going to be equal to 2 to the power of 2 times 3 to the power of 3 to the power of x over 5 to the power of 5 times 7 to the power of 7 to the power of x is going to be equal to, yes, this part is important, it should be equal to 1. And here in this part it's going to be equal to x is the common power for numerator and denominator. That's why it's going to be like this: 2 to the power of 2 times 3 to the power of 3 over 5 to the power of 5 times 7 to the power of 7. Consciously I'm not writing these values. What are they? Because it will be very difficult for us to find 7 to the power of 7. Then x is equal to, this is going to be, x is equal to logarithmic base 2 to the power of 2 times 2 times 3 to the power of 3 over 5 to the power of 5 times 7 to the power of 7 is going to 1 is going to be, and this answer is equal to 0. Why it is 0? Because logarithm base a, whatever a value, 1 is equal to 0. So the value here, if it is 1, this value is not important for us. It must be 0.